Welcome back. Let's talk about the solubility of salts. Substances that contains a cationic and an anionic part and are obtained from an acid-base reaction. We call those substances as salts. For example, upon reacting hydrochloric acid with sodium hydroxide, it results into the formation of sodium chloride. As the sodium chloride is consisting of Na plus and Cl minus ions, and this is obtained from an acid-base reaction, clearly this is a salt. Similarly, upon combining sulfuric acid with magnesium hydroxide, it results into the formation of magnesium sulfate. As this magnesium sulfate contains Mg2 plus and SO4 2 minus ions and is obtained from an acid-base reaction, clearly this is also a salt. Now, which among the salts will be soluble and which will be insoluble in water? For that, we have salts that are soluble, which include all those salts containing group first A and ammonium ions are soluble in water irrespective of the anions present. In the same way, salts containing bicarbonates, nitrates, chlorates, acetates, sulfates, and halides are also soluble. However, there are some exceptions in the salts of sulfates and halides. For example, the sulfates of lead, mercury, and silver, calcium, strontium, and barium will be insoluble, and the halide salts of lead, mercury, and silver will also be insoluble. So these are the exceptions among sulfates and halide salts. Now, how to remember these salts? We have a simple mnemonic, that is 1 billion cash, wherein 1 stands for group first and ammonium ions, B stands for bicarbonates, N for nitrates, C for chlorates, A for acetates, S for sulfates, and finally H for halides. So 1 billion cash is a simple mnemonic to remember these soluble salts. Now, salts that are insoluble include all those salts which contains carbonates, sulfides, chromates, phosphates, and hydroxides. But there is again exception in case of sulfides and hydroxides of calcium, strontium, and barium, which are slightly soluble. To remember these insoluble salts, we have a mnemonic, that is certain salts can't possibly hydrolyze. The first letter, that is C in certain, correspond to carbonates, S for sulfides, C of can't for chromates, P of possibly correspond to phosphates, and H of hydrolyze correspond to hydroxides. Point to note is that all those salts which contain group first A and ammonium ions, irrespective of the anion, are all soluble in water. And the second point is, a salt which is soluble does not mean it's completely soluble, and a salt which is insoluble does not also mean completely insoluble. So there is actually variation in solubility of these salts in water. This can be illustrated as, so we have the first illustration that says, identify the soluble or insoluble nature in following salts. So we have the first salt is sodium chloride, as it contains Na plus, that being a group first A member, clearly irrespective of the anion present, it will be soluble. Similarly, we have ammonium hydroxide. The presence of ammonium ion guarantees the soluble nature of such a salt. Now we have silver nitrate. As we know, nitrate salts are all soluble, so this will be soluble. Now next is lead sulfate. As we know, sulfates are soluble, but not with lead, mercury, and silver, calcium, strontium, and barium, so lead sulfate will be insoluble. Next, calcium chloride. So halides are soluble, but not with lead, mercury, and silver, so here it's calcium, so it will be soluble. Next, lead bromide. Halides are soluble, but not with lead, so it's insoluble. Phosphates are usually insoluble, but the cation is potassium, which being a group first A member, clearly it will be soluble. And lastly, we have calcium sulfide. Sulfides are normally insoluble in water, but there is an exception with regard to calcium, strontium, and barium, where it is slightly soluble. I hope you understand this. Now, I'm asking you to identify the soluble or insoluble nature of following salts. The salts are lead chromate, magnesium sulfide, zinc nitrate, ammonium phosphate, ammonium carbonate, and calcium bicarbonate. Once you finish up, please give the answers in the comments. Till then, take good care of yourselves. Thank you.